I'm Todd Schroeder, Director of Public Sector Digital Strategy here at Google Cloud, and I have the great privilege today to introduce Rocky Campione and Vint Cerf, who will be joining us as a panel as we explore some questions on the partnership between Department of Energy and Google Cloud. Rocky, if you'd like to introduce yourself.
How are you? I'm Rocky Campione. I'm a CIO at the Department of Energy. I like to say I have the best job in government. I'm in, I think, the most fascinating department with the smartest people, with the coolest missions, I should say. I think our general theme and culture is how do we give the people who are doing the work and the innovation across the department, especially at our national labs, the tools that they need to get the job done. And that could be a technical tool. It could be reducing the regulations or kind of the policies that we have to enable them to innovate. And it could be how do we make it easier to procure the tools that they need. And I think when we talk about all those three things, the deal that we recently struck does all three. So I'm really excited about that.
Thanks, Rocky. Vint?
Hi, I'm Vint Cerf. I'm Google's Chief Internet Evangelist, and I'm now a Vice President in the cloud operation, specifically looking at the public sector. So I'm really excited to have a chance to meet Rocky this way, although someday I hope it's face-to-face. And I have to say, I envy you the opportunity to try to shape what's going on over at DOE. You know, we're all about information here at Google. We process it at scale. We process it with pretty innovative technologies. And one of the things I hope that this partnership produces is an opportunity to explore how new processing techniques can produce better results for DOE. And so this has got to be a very, let's say, fruitful partnership, in my opinion.
Absolutely. And I think we're excited to see the innovations that are available to us. So it'll be great.
Rocky, how does the use of cloud technologies, and at least what you think of this partnership, complement the work being done across the labs day by day?
The work that we're doing at our labs, it's fascinating to me. Some of what we're trying to solve with our compute capability is mind-blowing when you think about, how do you identify the basics of life, or, neutrinos still boggle my mind. They're small, they go through everything, and everything's made up out of them. But then also even recently with COVID, we use our high performance computing to try to help map the genome or the proteins of the disease. But all of that's being done on our big iron. And we think that cloud computing, there's a great spot for that above our high performance computing, or to complement our high performance computing, so that we can dedicate that capability to where it works best, and then offload some of the other workloads into a cloud environment, with any cloud environment, in order to free up the resources and best utilize our resources across the department.
Vint, I know you have some experience in neutrinos and kind of processing lots and lots of data at scale. Any other information you wanted to shed on some of those comments?
Well, absolutely. Rocky, I completely agree with your point about being able to offload some processes from those very expensive and very, very important large-scale systems. I visited most of them at one time or another in my career. I sit on the ESNet advisory panel and the Advanced Scientific Computing Advisory Panel. So just a week or so ago, we got a good look at the diversity of things that the high-speed systems are attempting to accomplish. I think we bring some pretty innovative ideas to you and to others, specifically allowing multiple cloud systems to interwork with each other using Anthos, for example, and also allowing people to use special purpose processors like our TensorFlow capability. Someday, perhaps our quantum systems will be available online to DOE. And then there's the general large-scale query capability, the one that we exhibit when we index the entire World Wide Web and give people access to searching. And those same kinds of techniques are available or would be available to DOE for the data which is subject to that kind of processing, unlike the kind of super high-speed modeling which DOE does in so many different dimensions, so many different application areas. So I see this as a highly complementary capability, and so I'm glad that you do as well.
Pulling that thread a little bit more, Rocky, I know you've talked with the team as you've signed this agreement with the National Labs Power Administrations and other field organizations, talking around, scientific computing as a service, and how that might accelerate discovery, innovation, and really the advancement of the missions across your labs and your environment. Can you tell us a little bit more about, that announcement and where you see scientific computing as a service, the reduction of spending time and attention on commodity things and going more after, high value parts of the computing environment. Tell us a little bit about where you see that heading.
I kind of said it as a joke when we first started talking about this, where I said, what's really important about cloud computing, not just for the day-to-day business compute or kind of the business needs, whether it be email. I remember I sat down with Google the first time and I said, look, I don't want to talk to you about that. That's commodity. I want to talk about scientific computing as a service. What do you bring with your innovation that helps us move our mission along of basic science research? Where do I see it going is as you and all the other cloud providers, frankly, innovate, you're innovating cloud first. So the innovations that our scientists need and that our folks at the national labs need, engineers, scientists, it's all going to be in the cloud first. So first and foremost, we want to make sure we have those platforms available. Sometimes I call it setting the table for innovation. And that means having multiple cloud environments up and ready and able to be quickly used and utilized. When I talk about scientific computing as a service, as you bring in AI, as you bring in quantum, we're going to play bingo here, right? It's called the computing bingo, but AI, quantum, advanced analytics, they all kind of consign together. As those become available, I want to make sure contractually that our folks at the labs have an easy way to get to them so that they can quickly turn it on, quickly apply it where they deem it best, where they deem it most effective, and then really have them focus on solving problems and not focus on how do I procure something, how do I set up an environment, how do I get it ATO'd, and that's what my organization, the CIO's office, is working on. And first and foremost, it was setting up the procurement process. A lot of times I call it reducing the friction to innovation. So make it so it's easy to procure. Second, we want to make sure that their ATO, the security around them is done. We're working on that next. So those who are in the national labs and are looking at this, that's kind of a major focus next is how do we get standard ATOs that you reach in, grab the template, deploy it, and then boom, you're good. So that you're really not wasting time on what I do well is management, right? Or the management of the process, the back-end administrative. You're spending your time on thinking big thoughts, solving big problems. So where do I think it's going? I think we're going to move more and more into the cloud. We want, from a headquarters perspective, to move more and more to a place where people can just pick the compute that they need to get the job done. And really, again, reducing the friction in innovation, reducing the amount of work they have to do before they start solving the problem we're paying them to do.
So this raises a really interesting idea, Rocky. I have no idea whether this is entirely feasible, but just think for a minute. We schedule literally, it must be billions of jobs per unit of time, whether it's day or a week or something, but lots of them are scheduled on all those processors that we have. So you can imagine that we spend an awful lot of time figuring out where the hell does this job go and how do we get it all set up and then run it and do it in milliseconds for the users. So imagine for a moment that we think of all of the computing assets at DOE as this enormous collection of functional capability, and then ask ourselves, all right, can I use the cloud capability in order to correctly schedule or optimally schedule the jobs that need to run on all the various large-scale computing systems at DOE? And I have no idea if this is feasible, but you can think about optimality. You can think about the way in which somebody can essentially ask for a job to be run, whether it's a mix of our facilities, maybe somebody else's cloud facilities, maybe some of the supercomputers at DOE. Imagine being able to, let's say, easily lay out what your requirements are and have the system figure out how in the hell to schedule all that, deal with accounting and all the other things that is part of your headaches. Very excited about the way that you put this, because I hadn't thought about it as the management angle of this is as important as the absolute processing capability and maybe special purpose capabilities, because squeezing the last drop of computer power to these tough problems would actually be a big help.
You're hired. No, it would be. I'll be blunt. I'm probably that's probably not something we can solve in the next 6 months or year, but I think it's aspirational. Can we do that, right? Can we get to a place where it makes sense? I'm still, frankly, on phase one of, do we even have the platforms available, right? But I love that. I love that. It's visionary, aspirational. I think I'm going to turn to our National Lab CIOs and tell them that that's their problem to solve, and tell me what I need to do to make that happen.
That's right. So you're kind of talking about, reducing friction. Tactically, what does that look like? What do you want folks across DOE to know today about the real kind of strategy behind this, reducing some of that friction, and how to take advantage of it so you can get to the next chapter of where you're headed? Part
of the tactical is, one, getting this deal done. We're going to look at other cloud providers and make sure that we have the best price with the largest amount. I don't want to get too nitnoid here. The largest amount of SKUs are just that's already pre-contracted, so that when you need to do something in the field, you have a quick thing to hang it on. And there's some unique with the FAR and some of how we do contracting with labs. There's some unique things to do. So sometimes I say, can we take a 6 to 8 to 7 week procurement down to a week, right? And we're going to get some numbers on what those are. That's something we want to track. Another thing is we talk about ATOs, and again, it's great to talk big thoughts, but sometimes these little bureaucratic things get in the way, and they're important. We need to make sure we have secure cloud, secure systems. It's great to spend $1 million or $1 billion on doing research, but if you didn't spend the $100,000 securing it, what's the use? So that's the next big thing that we have to work on. How do we solve that? Not just for Google, but for every one of our cloud providers. And we're working with our national lab CIOs of what is the best way. We've realized one size doesn't fit all. As I will constantly say, the risk that Lawrence Berkeley National Lab is willing to take is far different than the risk Los Alamos National Lab is willing to take. And that's okay. And we're good with that. So if I do a one size fits all that meets Los Alamos, Berkeley will say, I'll never use it. If I do the one for Berkeley, Los Alamos will say, I'll never use it. So we'll see what the final results are. I think what we're going to end up is some templates. Like there's a scientific template, there's a national security template, there's a business template. And we use those templates so that when someone does say, hey, I need to deploy this, they can move it through our bureaucratic process faster than what it normally is. And I'm hearing horror stories of over a year or 6 months. I don't understand why we have cloud computing if you have an idea and 6 months later we're finally saying you can do it. That's a waste of time, money, and frankly, I don't think it's a good use of taxpayers' dollars. But we want to make sure it's secure, but we want to make sure that we can do that quickly and efficiently.
So as a taxpayer, I really applaud the attitude that you're showing, Rocky. A couple of things to observe. First one, I mentioned Anthos. This is our attempt to allow multiple clouds to share containers, for example, and be able to run code on different places, taking advantage of special purpose things. We've recently announced something called confidential computing, which might turn out to be of some interest. We use cryptography in a lot of our operation normally, but we've added some cryptographic capability in the processors themselves in order to run code that's shielded effectively by cryptographic means, even while the computation is underway. It strikes me that we need a common vocabulary. You can help us with this. The various cloud organizations offering their products and services through this, well, let me call it a basic ordering agreement which is a manifestation of an ATO. And what you want, I think, for your scientists is ease of getting access to the computing resources they need. And so pre-negotiations, standardization of the requirements that the computational facility has to meet for certain kinds of loads, all of that standardization and commonality will be helpful to you, but it'll be tremendously helpful to the entire cloud community, because having that commonality makes it possible for all of us to offer to DOE and others a menu which is understandable in terms of what its functionality is and what security levels it meets.
No, and you talked about confidential computing. We're really excited about that. And again, my general hypothesis is all cloud environments are extremely secure, and all cloud environments are extremely not secure. It depends on how you configure them. And again, I think you're right. If we can come up with some standard vocabulary and just some standard templates, we can just we can make it easier. And frankly, if you're a researcher on whether it be climate change or COVID, do you really know a lot about an ATO, or do you really care? You want to be able to say, here's what I need. I want this processing power. I want this capability. Let's go. And we're trying to get that. And it's not going to be tomorrow. It's not called a bureaucracy for nothing. But we want to make sure we shorten that time and focus on it, and make sure, again, the right amount of security. A mentor of mine, Tom Pike, would say, you want just enough, right? You don't want like too much, because then you're overkill. You want just enough security for the risk that you're willing to take. And we're trying to get that, and we'll get that with our partners too.
The use of the term risk here is precisely right. This is a risk management issue. It's not an absolute security issue. It's a risk management issue. And that is something that we certainly recognize, and as you do, that will help everyone if we get into the right mindset, where you're not trying to make every system run as it would need to if it were running special codes at Los Alamos, when in fact you're doing an unclass operation and you just like to get on with it.
I can use my brain power to think about the little things like ATOs and bureaucratic stuff. Let someone else use their brain power to solve real problems. Yeah. And give them the cycles they need, make sure they can do what they need to do, and we just make it easy.
Amen to that. Well, by the way, this is a real problem. I mean, don't undervalue what you're trying to accomplish here. It is a real problem, and if it gets solved, it lets us solve some other even more important problems.
On that thread, where do you think the next 12 months are headed here? Like, what are the big use cases and proofs of concepts? Rocky, both from your perspective or Vent, those that you're aware of in the environment that we're really keeping an eye on as the kind of gold stars for what is evidence of what will come even beyond the next year.
One thought that immediately comes to mind with the COVID situation in mind. Understanding COVID and the way in which it affects the human body is still has a lot of mysterious pieces to it. Piecing together correlations for the data that we have, or the data that I hope we collect, will be something that I know DOE has already invested heavily in. So understanding the nature of this disease and how it manifests, so we can detect it more quickly, so we can figure out what treatments are most likely effective and at what point in the course of the disease, could be a really powerful aid in getting past this persistent pandemic. So that's an example of the kind of thing that I would imagine could happen, especially making heavy use of our machine learning capability, just for example.
No, absolutely. And we started this prior to COVID, and it seemed in some ways kind of prescient that we're now in this, and I think it's even more important than ever. But I also look at, within the scientific community, a lot of machine learning. But what I might even talk about is some of the more mundane. We did a proof of concept looking at wellheads for legacy management. So, the ability to use, kind of, we're calling it AI, but to look or to identify a picture and to identify, does it need maintenance? Is it okay? sometimes even as simple as, does it have the proper markings around it? And before, a human would have to drive out and then have to record everything and then transcribe it and bring it back. Now you can take a digital picture. So that's step one. Maybe we can go to a drone. Even looking at power lines. So for our PMAs, we provide 11% of the bulk power to the United States of America. That's a lot of power lines, taking electricity from our Bureau of Land Management dams and Army Corps of Engineer dams and getting it to the American people. The visualization that we can use, using that to visualize to kind of help better maintain them. And those might not be as sexy as kind of COVID or as dark matter or, dark energy, dark matter, but they're also really important, and they're also immediate impact type of activities.
So when you think of the scale of the U.S. power grid, just think of all the parts that are in that system. Think about what happens when natural disasters come along, as they did in California, as they have in the Gulf states, wiping out power. Just keeping track of the state of the system, keeping track of where the assets are, keeping track of the logistics that are needed to recover. The supply chain situation, we had a problem, as you remember, with protective equipment during the COVID, but we have similar kinds of challenges when you're looking at supply chain response to a major disaster and rebuilding or reconditioning the power grid. So I can see these kinds of large-scale information management problems fitting well into the cloud environment, maybe better than it would fit into a more supercomputer, conventional scientific computing environment. And so that's the place where you and others like DHS and FEMA and so on could be combining your information in order to accelerate our recovery from some of these major events.
Absolutely, and it's something when we talk about the security of our or the resilience of our energy sector. So as a sector-specific agency for energy, DOE has that responsibility, and we think it's one of our more important responsibilities because nothing else works without electricity. Right? You don't have telecoms, you don't have health. I had given an interview and we talked about how we responded to COVID. And what I was saying, what I was most proud of is we made sure we could keep the electricity flowing because there is no ventilator, there is no hospital. If we're not up and running and we're not moving electricity where it needs to be.
There is another activity. It's our Argonne National Laboratory. Charlie Catlett, who used to be a CIO there, you might even know him, has gotten very much involved in monitoring cities for pollutants and the state of the city, the traffic and all the other things that we care about. And I've just hooked up a couple of guys in Oregon with Charlie to see whether they can be hypergolic when they work together. So the thing I want to emphasize from that little snippet is the diversity of what goes on at DOE. I mean, it is stunningly diverse. And that's the thing that I hope our partnership with DOE will contribute to, and that's dealing with the diversity and the computing requirements that occupy this huge spectrum of requirement. So, I mean, Rocky's got just an amazing constellation of challenges in front of him to try to make all this work.
What I think I'm lucky is I've got a number of great colleagues, whether the National Lab CIOs that really understand what's going on and how we need to push the science. And I really rely on them to say, what can we do that's helpful? Really, this is due to a lot of hard work from Lawrence Berkeley National Lab, from Ron Austin on my team, but more importantly, we hope that what we're doing here and some of what our concepts really help people at the national labs and even at our power marketing and some of our other sites and facilities really get their job done and focus on what they need to focus on and not focus on a procurement issue or just bureaucratic, right?
Well, Rocky, I can't thank you enough for spending some time and all the work you and the team across headquarters and the labs have put into this. I want to kind of pay forward our thank you from our team as well. Appreciate you spending the time here today with us to share some of this information more broadly. across the DOE, and really the ecosystem that supports DOE, right? Because it is very much just about that partnership and where we can advance science as it relates to each individual lab's mission. So thank you for your time, Vint. Thank you for your time and perspective and expertise as well. Until next time, I hope you all do well.
Hey, see you on the
Thank you.